If you want to become an AI engineer in 2026, here is the exact 6-month roadmap that will get you there. And I know what you're thinking. 6 months sounds way too short, right? Don't you need a lot of years of experience, a PhD? Don't you need reading a lot of research papers every day and somehow keeping up with everything that's happening on LinkedIn? No, you really don't. Here is why. An AI engineer builds applications powered by AI, which is primarily large language models. We are not training models from scratch. We are not doing research. We are taking powerful AI capabilities that already exist and turning them into products that solve real world problems. And that, yes, you can learn that in 6 months if you're focused. Now, if you're watching this video, you're probably feeling two things at once. On one hand, you're excited. AI engineering sounds incredible. Every week there is something new, whether it's a new model, new tools, new startups. It feels like the most exciting time to be in this field. But on the other hand, you're probably overwhelmed, maybe even intimidated. Everyone else seems to already know what they're doing, and you're thinking, how am I going to ever keep up with this? Let me tell you that feeling is normal, but it is not accurate. And in this video, I'll walk you through exactly how I would approach this starting from scratch, month by month with real project and very honest advice. If you don't know me, I'm Aishwarya Srinivasan. I've been in the ML and AI space for over 10 years. I got my master's in data science from Columbia University, and I've worked at companies like Microsoft, Google, and IBM. Currently, I lead AI developer relations at Fireworks AI, which is one of the top AI startups out there. So I've seen what actually gets people hired, whether it's in big tech or fast moving startups. I'll share all of my favorite resources at the end, so definitely stick around for that. Now, the question is, who is this roadmap for? The most common path into AI engineering is definitely software engineering. If you've been working as a backend or a full stack developer, you already know how to build systems, you know how to work with APIs, and you know how to ship to production. Adding AI on top of that is pretty natural, but that's not the only way to get it. I have seen front end developers also make this transition. If you're building user interfaces, you understand how to create great experience. And AI engineering is increasingly about AI powered interfaces, whether it's chatbots, co-pilots or assistants. I've seen product managers switch into AI engineering as well. If you deeply understand user problems and you're willing to get technical, you have a massive advantage. What I've seen mattered in most cases wasn't their previous title, it was the willingness to put in the effort that you need. Now, here is the good news. You don't have to be an expert coder to start. You need to be comfortable enough with Python to call APIs, to process data, and build basic applications. That is a much lower bar than most people think. Now, if that sounds exciting, let's build your roadmap. So, starting with month zero. I call this month zero because this is the part everybody rushes through or skips. Then a few months later, they are making weird decisions because they never understood the landscape that they're operating in. So, month zero is about building your mental map of the entire ecosystem. By the end of this month, you should be able to look at any AI product and understand roughly how it works, what stack it is using, and what trade offs the builders made. So, let me break down that stack for you. At the foundation, we have the models. These come in two flavors: proprietary models through APIs like OpenAI and Anthropic, and open source models that you can either run yourself or access through inference providers like Fireworks AI or Grok. Above that, we have the retrieval layer. This is how you give AI applications access to specific knowledge, your company's documents, the product information, whatever you want to put in. This involves embeddings, vector databases, and search. Then we have the orchestration layer. So frameworks like LangChain or Llama Index that helps application logic and tie everything together. Finally, the application layer, which is the actual interface that users interact with, the APIs that you expose, the integrations that you build. So, what you should actually do this month is get your hands dirty with different models. Sign up for OpenAI, sign up for Anthropic, and at least one open source provider. Try making some API calls to these large language models. Compare the responses and then notice how different models have different personalities, how they have different strengths, and how different failure modes. This direct experience is invaluable. Then I would say you need to explore the tooling landscape. You don't have to commit to any particular framework yet, just explore. Look at LangChain, Llama Index, and the OpenAI SDK. Read the docs, understand what problems each tool is solving, and then study how existing AI products work. Pick 5 products that you admire. let's say ChatGPT, Perplexity, Cursor, and whatever. Then reverse engineer them. What is probably happening behind the scenes? And then make decisions about where to start. Pick one model provider to learn deeply. Pick one framework to build with. You can expand on that later, but starting focused gets you further faster. Then in month one is where you go from understanding the landscape to actually working with models efficiently. And I need you to hear this. Prompting is not a soft skill, it is engineering. The difference between a prompt that kind of works and the one that works reliably in production is huge. And that difference comes down to systemic thinking. So, first, understand how these models work conceptually. You don't need transformer architecture details, but understand tokenization, how text gets broken into pieces, and why it matters for cost and context limits. Understand context windows, how much information a model can consider, and what happens when you exceed it. Understand things like temperature and other parameters and how they affect randomness and creativity of a model. Second, learn to write prompts that actually work. Clear instructions matter. So instead of saying just summarize this, try something like summarize this document into 3 bullet points, focusing on key decisions and their rationale. Learn few shot prompting, giving examples of what you want. This is incredibly powerful for consistent outputs. Then learn structured outputs. Getting clean JSON from a LLM sounds simple, but it is tricky. So learn response formats, output validation, and how to handle it when the model ignores your instructions. Third, understand the practical stuff. Streaming responses so that users don't have to wait for the complete generation of the answer. And then things like error handling when the APIs fail, rate limits and retry logic, cost management, etc., because every token costs money. Now, in this month, I want you to build 3 small applications. A domain specific assistant. So, pick a topic that you know well, build something that answers questions knowledgeably. This teaches you system prompts and context setting. Then, build a structured data extractor. So, start with messy text and extract structured information from it. This teaches you output formatting and validation. Then, build a multi turn conversational app, something where previous messages matter. This teaches you conversation history and context management. And throughout all of this, develop an iteration workflow. When a prompt fails, don't randomly tweak it. Analyze what went wrong, form a hypothesis, make a targeted change, and test it again. This systematic approach separates consistent results from the lucky ones. Now, month 2 is where you go from experimentation to real application building. The key shift here is you start thinking in systems and not just individual prompts. Real applications have multiple components working together. Whether it is handling input, whether it's processing, calling multiple prompts or models, whether it's handling errors, whether it's presenting results. The most important concept you'll learn in this month is tool use, also known as function calling. Here is the thing about LLMs on their own. They can only generate text. They can't check calendars, they can't send you emails, they can't look up information, or they can't even run code. Tool use is how you give them those capabilities. You define functions that the models can call. It decides when to use them and with what parameters. Your code executes them and then returns the value. This is fundamental. Almost every useful applications involves the AI actually doing something, not just talking. So now in this particular month, I want you to build a tool using assistant that takes real actions. It could be doing things like searching the web, reading files, calling an API that you care about, and the key here is doing real things, not just chatting with the user. This needs to be an application with multiple steps, something called as chaining. So build an application where one LLM informs the next. It could be a research assistant that searches, synthesizes findings, then formats everything for the user, or something that handles different input types. Whether it is text, images, if you're using multimodal model, it could be files, and this flexibility teaches you what real applications really require. So I would say pick one framework and learn it well. LangChain is popular with tons of documentation. Llama Index is great for document processing. Or just build more from scratch with SDKs, and understanding what frameworks do under the hood really matters regardless of what you use. Here is what you'll learn the hard way this month. Token costs add up fast. A prompt using 2000 tokens when 500 would work is 4 times more cost at scale. And latency matters more than you think. Users are impatient. A 10-second response might be correct but practically unusable. And prompts that work 90% of the time are not production ready. That 10% failure will drive users crazy. So think about these edge cases from the very beginning. Then in month 3, pay really close attention here. A huge chunk of real world AI engineering is RAG, which is retrieval augmented generation. This is how you give AI applications access to specific knowledge, whether it's company documents, product databases, or internal Wikipedia pages. I'm not talking about flashy demos, I'm talking about reliable systems that work consistently over time. So, here is what you need to know. Starting with chunking. How you split documents matters more than people realize. Whether it should be paragraphs, sentences, fixed token count, should you preserve the structure? There is no single right answer. But your choice dramatically affects the retrieval quality. Then we have embeddings. This is how text becomes numbers that capture meaning. Different embedding models have different strengths. Some handle semantic similarity better, while the others handle long passages better. Then we have vector databases, where you store embeddings and search them. Popular vector databases are Pinecone, Viviet, Chroma, and Qdrant. Now, each of them have different trade offs around scale, cost, and features. Then you have retrieval strategies. Simple similarity search is just the start. You also have hybrid search, which combines semantic and keyword matching. Then you should learn about re-ranking, which uses a second model to improve the results of retrieval. Then you also have query transformation, which rewrites the questions to get better retrieval. Here is the critical insight that you need to know. Most RAG systems fail because retrieval is weak, not because the LLM is bad. You feed the model with irrelevant context and the output suffers no matter how smart the model is. So in this particular month, I want you to build one serious RAG application end to end. Use data that you can find publicly, whether it's open source documentations, papers, articles, etc., and then build the complete pipeline: ingestion, chunking, embedding, storage, retrieval, and generation. And then build an interface where people can actually go and use it. Here is what will set you apart: evaluation. Most people have no idea if their RAG system actually works well. Even basic evaluation puts you ahead. So create a test set with questions where you know the answers and which documents should be retrieved. Measure whether you're retrieving the right documents or not, measure the answer accuracy, and track these metrics as you make changes. This evaluation mindset is incredibly valuable and surprisingly rare. Then month 4 is where things get very interesting because we have agents. Agents are AI systems that take multiple steps to accomplish goals, which is deciding what actions to take along the way. Instead of just responding to a single query, an agent might search for an information, analyze what it found, realize that it might need more, so search again, and then synthesize everything and then finally respond to the user. This is where AI engineering starts to feel like building genuinely intelligent systems. So, this is where you need to understand the core agent loop: the observe state, decide on an action, execute, observe the result, and repeat until done. Then, secondly, understand planning. How do agents break down complex tasks? Here we have different approaches. One is chain of thought, then the other is tree of thought, along with other planning frameworks. And third, understand memory. Short term memory within a task, long term memory across sections. How do you actually implement these? Then, fourth thing, understand error handling. Agents do fail a lot. APIs often error out, tools return unexpected results, agents go down wrong paths. So you need to understand all of this. So this particular month, what I want you to build is build an AI agent that accomplishes a real multi-step task. Maybe a research agent that takes a question, searches through multiple sources, synthesizes what it found, and produces a final result, making decisions about what to search based on what it's discovering. Or you can build a coding agent that reads a code database, understands the functions, makes the changes, and verifies the work. Or you can even build a data analysis agent that examines a dataset, decides what to ask, and runs analysis and then finally presents the finding. The specific domain matters less than building something that genuinely reasons through multiple steps. Through this process, you'll learn that agents are expensive. Each step involves LLM calls. 10 step might cost 10x what a single turn application costs. Then you learn that agents are slow. Multiple round trips actually add up on time. So think about user experience, streaming progress, and showing what's happening. Then agents are unpredictable. With the same input, different paths, testing is hard. You need observability. You need logging what the agent does and why. Simpler agents are usually better. So before building a complex agent, ask yourself if a simple chain or even a single prompt could work. Then in month 5, we are going to focus on deployment and production. This is going to be your biggest edge because this is where most people stop learning. So projects running only on your laptop create zero business value. A deployed system that real users can use and is running reliably is what is very important. So I would highly recommend you learn Fast API for building APIs. It is the standard for AI deployments. Then I would say learn Docker for containerization. Your app that runs everywhere is what is reliable. Then learn basic cloud deployment. You can use tools like Railway, Render, or Fly.io. It makes it easy without having DevOps experience. Then take your RAG system or agent from the previous months and just deploy it. You can add logging and observability. For example, what requests are coming in, what's the LLM generating, can you debug when the things break. So use tools like Langsmith, Langfuse, or even just structured looping, which gives you visibility. Then I would say get into latency monitoring. How long are requests taking? Where are the bottlenecks? Then I would say get into cost tracking. How much are you paying per request? How much are you paying per day? How much are you paying per user? Then look into error handling. What happens when LLM APIs time out? When do rate limits hit? When do models return garbage? Handle these things gracefully. Then look into caching. If someone asks the same question twice, maybe skip the LLM call entirely. This dramatically reduces cost and latency. So here are some practical tips. Start with the simplest deployment that works. Use environment variables for API keys and never hard code your secrets. Always set up for health checks and always set up for basic alerting. This production mindset is what hiring managers mean by experience. It is not about the number of years you've worked at a company, it is about your experience in building production level systems. Then in month 6, it is time to specialize and prepare for your interviews. I would say at this point, you need to stop being a generalist. Look at real AI engineer job descriptions. What are the skills that keep appearing? What are the tools that keep appearing? What kind of projects are they requiring from you? Pick a direction based on your interest. Whether it's user-facing AI products which focuses on application development and great user experience, or if it's infrastructure which involves deployment, scaling, ML ops for LLM applications, or if it's agents and autonomous systems which has complex architectures and cutting edge patterns. Or it could be in open source models where you're fine tuning using LoRa, quantization, and optimization. I would say build one capstone project you can walk through confidently in these interviews. You can also combine multiple skills. You can combine RAG with agents, deployment, and evaluation. Prepare your explanations properly. Interviewers want to understand how you think. Why this problem? Why this approach? What trade offs did you make? What broke and how did you fix it? What would you do differently? And the other thing I highly recommend people to do is build in public. If you are building portfolio projects, share that on LinkedIn, Twitter, GitHub, Substack, wherever you're comfortable. Write about what you're learning, and visibility definitely creates opportunities, so you need to do that. So let me leave you with this. AI engineering is genuinely new, and the playbook is still being written. That is scary, but it is also exciting. The barriers to entry are low than traditional engineering. You don't need a CS degree, you just need to build things that work. This field rewards builders over studiers. You can watch tutorials forever, but none of it would matter if you are not building. Every project teaches you things that reading never will. Resources are in the description below, organized by months. If this helped, please do subscribe for my channel for more AI engineering content and drop a comment below. Where are you starting from and what should I go deeper on? I'll see you in the next one.